My name is Mali. I'm based in Japan, and I'm in charge of the region manager, Japan, Australia, New Zealand, and Singapore. I'm here today with my colleague Valen over there. He's based in Sydney. We are increasing local support members here so that we can communicate more face-to-face. So today's my talk because we are running a workshop. It's a little bit brief overview again, the nanopore sequencing feature and application and what nanopore sequence that we have, and also that we have a lot of information, training, content, video in the community side, and also the publication resource center. But because we update information quite often, sometimes people get lost, so many information overwhelmed. So I'm going through the community, where you should look at it, where the useful information, how to find it. I will show those information as well as the application. So this is a nanopore sequencing. We call it nanopore sensing. Any DNA or RNA fragment during the library preparation, we attach the adapter sequence. The green part is multi-protein in adapter sequencing adapter. So during library preparation, you attach to those sequencing adapter, and the sequencing adapter split double strand into the one strand and pushing the molecule into the nanopore hole. And the membrane, which nanopore protein is embedded into the synthesized membrane, and the membrane having a high resistance. So any molecule going through the nanopore, we can measure those molecules as the ion current change. And those ion current change is measured like this, the format. We call it the squiggles. Using deep learning algorithm, we convert this signal AGTC. So that is a very basic principle. Important point is that we do not use any fluorescence. We sequence the molecule as it is. So using this principle, we can sequence the DNA and RNA. Sequencing RNA is not sequencing cDNA, sequencing the RNA molecule as it is. And also the methylation or those modifications appear as the shape difference, and we can capture those difference as the ion current change. And the throughput, it depends on how many nanopore and how many electric sensors are sitting in the flow sensor array. So we can, this is just one nanopore, but we can embed it to hundreds and thousands nanopore in the one sensor array. We can really control well this, control the number of the nanopore in the flow cell very well. So this is the brief example of how we detect the modification. Now we can detect the DNA and RNA modification. In the DNA, we can detect 5-methyl-C and 6-methyl-A. We have a model and we have software. And for the RNA, we can detect the 5-methyl-C. We also have a model and a software. So when you get the DNA sequence, genome sequencing, you can get also modification information just for free. You don't need to do extra experiment sequencing. You can get you can use the same squiggle information to detect those modifications. This is a simple picture drawing of the library preparation. Mainly, we have two types of ligation method. One is the ligation method. Another one is the rapid method. Rapid method, we use the rapid chemistry, and a slightly different the way of attaching a sequencing adapter. But both library preparation, the main point is attaching sequencing adapter, having a motor protein that navigates the molecule into the nanopore. So this ligation method, it takes 60 minutes, and the rapid kit just 10 minutes. 2 steps and just 10 minutes. So because it is very simple, the ligation method, especially rapid kit, the people can do sequencing in the field, and our device is so small. Now for sequencing MinION devices, the people who attend the workshop, you're going to see you already see that this is a MinION device. It's very small, it's very portable. And our sequencer, as long as the adapter is attached in the end, you can sequence. So the length is we are very flexible, and because we set for the genome sequencing, we set the 1 or 1.5 microgram input material. You can do fragmentation if you want to do, so that you can sequencing the amplicon, and also you can do the genome sequencing without the PCR amplification, which means that you don't introduce any amplification the bias into the sample. And we have the MinION. I'm going to talk about the Promethean a little bit later, but now we have several different primer, sequencer, and the throughput is very different because the flow cell is different. And also because the protocol is very flexible and chemistry is very flexible, and probably yesterday, today you're doing the DNA preparation. So that if you share the DNA, the throughput would be increased. If you didn't share the DNA, because the number of the molecule is lower than even the same using the same amount of DNA. If the length is higher, molarity is going to be lower. So the number of that adapter you can attach to the end would be slightly lower. But people really adjusting those protocol, like the John Tyson today, he came over from the country, and people adjusting higher length, longer length, and high throughput. And people really adjusting, and we are doing a really good shape. Even the N50s, in this case, like the 30 or 50, still really nice the throughput you can expect this protocol. So this is a little detail of the MinION device, which I'm holding right now. This is a MinION device, so you can use this one connecting the computer, and this one is a flow cell. And here we have a 512 sensor, 512 sensors, and the 2064 nanopore embedded in. One sensor channel has 4 different nanopore, and over the time we are switching to the one nanopore to another nanopore, making sure that you always use the best condition of nanopore. We started selling the MinION device around 2014 and 2015. We are 3 or 4 years old, the sequencing company, but the throughput increase is very dramatic. We changed the chemistry, we changed the nanopore, and we changed the software, and that each the improvement applied the throughput increased a lot. Right now, I see that people generate 10 giga, 20 giga. Some customers start generating 30 gigabase. And internally, using the old R&D implementation, I heard they hit like a 50 gigabase. This is not all chemistry and membrane not available, but internally, we see that it's possible. This small MinION device can generate even 50 gigabase in the future. And people are always asking about accuracy, because when we released the MinION, the nanopore sequencing, at that time our accuracy actually is 70 or 80%, and the throughput is less than 1 gigabase. 3 years ago, when I joined the Nanopore, I was a technical support, and my first line, I always said, if you hit 1 gigabase, you are okay. And fortunately, I could hit 1 giga, but that was kind of even internally, that's our expectation. But right now, the accuracy improved a lot and throughput improved a lot. People in the first time easily get 5 or 10 gig and more. And in this case, the accuracy now, the 1D accuracy, the sequencing one side, right now that's our chemistry, but the DNA, we fit like 2 different algorithms, and the fast and accuracy mode. Accuracy mode already hit the 95% accuracy per lead, and RNA as well. And this is the per lead accuracy. When you sequence the same region a couple of times, generating a consensus sequencing accuracy already hit close to the Q30. Right now, we are selling 9.4 and our 9.4 version Nanopore and our 10 version of Nanopore, 2 type of versions, different chemistry. Our 10 we just released, and we found where we need to improve further. So we plan to release our 10.1. So you don't really need to rush, but the benefit is our 9.4 version of a Nanopore, we know where error comes from. The most of error coming from the home polymer lesion. And AL10 was created to overcome those difficulties, challenging lesion. However, we have some plan releasing a new version of the base calling for AL 9.4, and that is also helping to reduce the homopolymeric lesion error. So because we are still in the development of R10, I recommend just this, unless you have a really, really serious problem for the home polymer lesion, I recommend staying R9.4, and you can also testing upcoming the new base call. It's called the read links encoding. The another one, the Nanopore's really good point is the real-time base calling, real-time sequencing. The real-time sequencing is not only for useful for the infectious disease, really like a rapid diagnosis people. Real-time sequencing, bless you, bless you. So real-time sequencing, you can monitor your sequencing real time. If something wrong, if you think, oh, I want to have a more throughput, you can actually wash in the middle of the run and do the sequencing, apply the more sample there. So that this is the run time and this is the total yield. You maybe like this, the going to the plateau, but over the 24 hours, you see that, okay, I want to get the more throughput. Washing the flow cell and clean up all the nanopore. Over the run, we see the nanopore stack some molecule, something, and you cannot get the good yield. But now our new washing kit includes the nuclease and cutting those stacked DNA into pieces, clean up very nicely, and you can add the new samples. This is really helpful to increase the throughput in the same sample, and also, or sometimes you want to run a different sample in the same flow cell. So in that case, the previous washing kit was not strong enough, and the people are really concerned that the carryover. So this one is the barcoding one, and the second one with the new barcoding. But still, we see the previous one, the carryover. But using the new nuclear wash the kit, we almost all sample very nicely cutting over and more than washing away 99.9% of the previous sample. So this is a very powerful washing kit. You can use the increasing throughput, also you can use a different sample on the same flow cell, which really helps to reduce your running sample cost. And some hints and the tips. I'm sure you already learned a couple of the tips, but you have to be very careful. But this is just a reminder, and our technical support team always saying that the quantification. So because it's very important for us what's the concentration of DNA and RNA and how many molecules there. Not just the concentration, but also the measuring length is very important, and the quality and the purity is very important. So the DNA, RNA, we have specific the quality, the criteria that gives you the good idea if your DNA is clean enough. So I mentioned several the good point of the nanopore sequence. What application you can apply? We have really long lead, like 40, 50, some lead even like 100 kilobase. Very long lead is good for the assembly and the full-length transcriptome, and also definitely the de novo assembly, very, very helpful. And the real-time infectious disease pathogen, and you can review your sequencing in real time. And like molecule sequencing, definitely this is helpful, the DNA or RNA molecule and modification as well, and they're very portable. You can sequence literally anywhere. And the scalable and cost efficient. I'm going to show you the different type of sequencer, but now we have a different range of the sequencer, and the learning cost is different in each sequencer. So this is a list of applications people are using in Nanopore sequencing. I don't have time today for showing the detailed paper, but I'm going to show you how you can find the latest publication. Almost every week we see the new paper coming. Center. So definitely whole genome sequencing and target sequencing. So you can do Amplicon, and also we have the Cas9 enrichment protocol available. You can do it. And RNA sequencing, we call it direct RNA. Modification is possible, and metagenomics, and of course epigenetics. So then what device you can choose? Now we have so many sequencers available. So the left two are still in development, but the Minayan and the Flongle is a very small throughput the flow cell using same device. Minayan MK1 we just start shipping to the customer. And the GridION X5 is the 5 flow cell you can set, 9 flow cell you can set for the 5 throughput you can expect. And the really giant one is the PromethION. I'm going to talk a little bit more. But the other day, I met a very interesting customer. He got a very unfortunate Flongle, but he was very excited. Money, I got a very good result. I got a Flongle. Flongle, we expect a 126 channel and 126 nanopore embedded in. But very, very unfortunately, he only got a 7 nanopore. And he was very disappointed. But he already he just targeting one gene. It was a patient-related one, and he really wanted to know what's transcript difference from the healthy child, and he sequenced. And those 7 nanopore generated 20,000 lead. That was good enough to classify the isoform difference, and he could tell different amount of how much healthy child same transcript those lead, and how much patient-specific transcript from those 7 nanopore. So you can really imagine small number, we can really scale up, but also scale down. Another customer sequenced sequenced 70 patients in a neurological disorder patient, and he sequenced using PromethION and found a really nice repeat pattern. He scaled down to the MinION, specifically using Cas9, and they specified the repeat pattern, and that repeat pattern is actually associated with the patient the symptom. That was neural disorder, so the dementia and the weakness were related to repeat pattern. Now he's testing Cas9 using Flongle. So you can really scale up and scale down. So PromethION data analysis, actually he published a paper in Nature Genetics this July, so if you're interested, I can refer the paper. So this giant one, the PromethION, is really the monster, the sequencer. The maximum is 7 terabase. You can sequence using 48 flow cell. This PromethION, each flow cell is roughly 6 times of a nanopore embedded than MinION flow cell. So from one flow cell, you can expect 50 gig to the 150 gigabase. The person has a good experience. The 160 gigabase is better. So the 150 gigabase. And very good things of this, the high throughput, the PromethION is this 48 flow cell. You can really run independently. So you don't need to wait other people's data. If you have the data, you can start running the one flow cell. And when next sample coming, even during the run, you can set a new flow cell and you can run sequence. DNA run, RNA run in parallel together, and everything real time. If you notice, one of the flow cell is running wrong. Running library seems to be not good. You can just stop those one, and you can washing the flow cell, and you can re-loading the flow cell. The PromethION, we start shipping the flow cell. That's 2017. At that time, we were roughly the 50 gigabase, and then now throughput is increasing. People see like 50 or 100 and 130. And internally, we hit the 220 gigabases. So this one is also, we still have a lot of the space to increase the throughput in the PromethION. So this one is really like a big the cost calculation, but we have several different tier of the bulk order. The biggest bulk order purchase per flow cell, the cost is down to $625 US. And the flow cell, that is the flow cell cost, and 100 per kit per sample. So if you purchase a really big flow cell, you can down cost to the 720. But this one requires 1.8 million US dollars for the bulk purchase. So but even like a small amount of the bulk order, the price is 1,700 US dollars or the 2,000 US dollars. It's not that expensive. And the one flow cell can generate 100 gigabase. That means the study coverage of human genome for this cost. And because we expect the throughput will be increased 200, 300. So you can multiplexing whole human genome to one sample in the near future. So what people are doing using the PromethION, because the one genome sequencing is not difficult anymore, people start doing 100 tomato genome in 100 days. And they finished this genome and genome sequencing already, and they created the de novo assembly software, and they are going to publish the papers. And this is a US customer. They sequenced the 11 human genome in 9 days. And this customer is also the consortium member. It's called the telomere to telomere, using ultra long read, the sequencing entire genomic sequencing, including the centromere. This is Chinese customer. They already sequenced 600 human genome, but their target is they have a 2' ion, and they plan to sequence 100,000 Chinese genome, building a structure variant database. So it's not creating just one genome, but the really whole genome population analysis error is coming, and I see those in the data, in the customer's data. And then our protocol and the sequencer, the sample preparation and DNA extraction QC is very flexible, and usually customer run some data, the raw data, extract DNA, the library, and the data answer. But usually once people get the data, they see like, oh, I wanted to have a longer lead. I wanted to have the more throughput. So then you need to go back to the where you can improve. Is it a library preparation? During the library preparation, you lost some DNA. During library preparation, it's something DNA sharing occurred, or sometimes you really need to go back to DNA extraction part. So we start collecting some DNA extraction method in our community site. Community site, we add more and more DNA extraction method, and not just the DNA extraction method, but the comparing a different DNA extraction method, and also showing what lead length distribution you can expect. And sometimes people see community site has so many information, especially for people who just start using it. Nanopore sequencing, it's really overwhelming. So I'm going to run through the Nanopore community site and also the publication site. So this is the the community site. To move this one. Still here. So this is the community site, and I log in my account, and once you purchase this Ion starter pack, you can access this site, and also that you can register before purchase. And at that time, not entire information is available, but you can see the protocol and some information is already available. And so this one, for the people who just started, definitely I wanted to check the getting started site. So the getting started site. We have quite a good online courses available now. I mentioned a couple of the tips and tricks, and also some of the sample sensing information. But you can actually watching this video running. So what is introduction nanopore technology and introduction and how to look at the community side and like a library preparation. Our technical service member is telling you what is library preparation you have to do.
Hello, yes. I'm Hazel Johnson, and I'm a Technical Services Specialist at Oxford Nanopore Technologies. In this video, I'll be taking you through an overview of the various options available to prepare your library prep, ready for sequencing.
And also the variety of protocol is available from here. LSK 109 is our most popular kit, and when you click this one, related to protocols available. Because our kit is so flexible, even just one kit actually having like more than 10 protocols available. So using the LSK1, you can do the genomic DNA, of course, the PCR amplicon, and if you want to have a really start the low amount of the DNA, you can do the whole genome application combining a QIAGEN kit available. And as I mentioned, we updated quite many things updating. So this is the place you can check what's new. And here there is a tab, it's called the release. So this one, you can see the timeline of what we release. Almost like a couple weeks, each couple weeks we release something, software, protocol, and some new kit available. And if you want to know a little more digest, so what's something you can check here. So this updating, so what's the really hot topic of the new publication and the new kit and the new event, you can roughly see the what I shouldn't miss. We kind of nicely summarize this one. And we go back to the dashboard. I highly recommend when you do sequencing, checking if any new software is available and if it's good to update or not, because if you have something trouble over technical service people asking you to upgrade the software, so it's worth checking if your software is the latest version and what is the new version, the new feature is added. And also that you can see that this one is when those are updated. Now you can see that quite often that we updated the software. Very important. And sometimes you think, oh, this is still too much. I want to talk to someone. Of course, you can email me or the Warren, but also that you can just contact to the support. And contact support. You can also book technical support call, like roughly the 1 hour length, and contact technical support and what's your problem, and say the device and the not QC side, something strange things happening. And entering like a number, and the next, and some information. Sometimes while you're doing an experiment, you really need urgent help. And you can finally connect to the live chat. So right now we have a 2 technical service person based in Singapore, and the Singapore time zone wise, you can connect to the technical service by live chat. While you're at the lab doing experiment, you really upset, oh, I don't know if I should keep doing it or I should stop it. Those kind of things that happening, you can contact the customer service. And also the good point is this FAQ, we are really defining this FAQ. For example, the library preparation and the storage, can I store my library? This is a very frequently asked question. It's already somewhere here. Flow cell, yeah. So if you're relatively new, maybe that you can check this information as well. And also the search function is available. The search function is available. So yesterday, I'm sure the John Tyson mentioned that he's the Rocky Mountain project, and that one is he made a really nice post. The Rocky Mountain Adventure DNA, how to get the really high molecular weight. He's posting, so our customers posting their experience, and there's some questions to the community. Very, very lengthy, the nice detail that he created. And you think, oh, that's very, very informative. And maybe you want to follow whatever John said. In that case, you can follow him so that you don't miss his post. Those experienced customers posting something, making a comment, suggestion, answering, you can follow those customers. Time by time, our product management team is posting here, so that of course you don't want to miss this information. You can follow our product management team as well. And just quickly, I want to show our publication site. I didn't have time to talk through the publication, but when you go to the resource site, now we have some filter function.